All right, so last set of examples is actually like an important thing to understand when we get into calculus, when we start looking at taking derivatives of composite functions using something called chain rule. You have to be able to look at a composite function, like we're going to see in these examples, and be able to identify the inner function and the outer function in the composition. Okay, so for these examples here, we're asked to find functions f and g so that f composed with g is equal to h. Okay, so again, that's going to make h of x, if that's equal to f composed with g, that is equivalent to f of g of x. Okay, so g of x is the inner function in the composition, and f of x is going to be the outer function in the composition. Okay, so when we look at number one, we have h of x, which is equal to the quantity 2x plus 3 raised to the fourth power. Okay, hopefully you can look at the function h of x and see that h of x is the composition of two functions. Okay, so I think like the most straightforward way to look at this, and the best way to look at this as far as like how you're going to need to identify this in calculus, is when you look at that composite function h, what is the inner function in that composite function? Because the inner function is going to be g of x. When we look at that composite function h, looks like the inner function in that composition is 2x plus 3. What function are we plugging 2x plus 3 in the place of in order to make 2x plus 3 raised to the fourth power? We're going to plug that in the place of x to the fourth power. Because if I want the function h, if h is f composed with g, then we're going to take that function g of x and plug it in the place of x wherever we see the function f. Okay, so again, that's the most direct, most straightforward, probably best way to look at that composition. But there are a number of different ways that we can do this. Okay, so here's what I want you guys to do. I want you to pause the video. I want you to come up with two additional sets of functions f and g, so that f composed with g is equal to h. All right, so again, pause the video, give that a try, and then come back and we'll look at two other ones. Okay, so again, when you guys work this through, there are a ton of different ways that you can do this. One that's super, super easy is we can make g of x equal to 2x plus 3 raised to the fourth power. And I can make f of x equal to x. So those are two functions, f and g, so that f composed with g is going to be equal to h. I don't know why that happened. Sorry. Okay, so again, f of x was equal to x. Another one that we could have done is I could have made g of x like equal to x. And what function am I going to plug 2x in the place of x to make f composed with g equal to h? Well, I can plug that into x plus 3 raised to the fourth power. Because again, if I'm going to do f composed with g, I'm going to plug 2x in the place of x in that function, which will make 2x plus 3 to the fourth power. And you guys could have come up with a multitude of different functions f and g so that that happens. Okay, Let's do the same thing with number 2. So with number 2, we're given the function h of x is equal to the square root of x squared plus 1. So again, if we want our functions f and g, the best, most straightforward way to do this is your inner function g of x is going to be x squared plus 1. And then your function f of x is going to be the square root of x. And again, like when you guys get to calculus, that's going to be the best way for you to interpret this. Okay, I'm going to make things a little bit more difficult for you here. So for number 2, I'm going to pick a function g of x. I'm going to pick it to be x plus 1. I want you to find the function f of x so that f composed with g is equal to that function h. All right, go ahead and pause the video. Give that one a try. This one should be a little harder for you to work with initially. Okay, so let's see how we did with this. So if my function g of x is x plus 1, okay, I know my function f of x has to have like a square root of x squared with it. Okay, so I'm going to like work out the calculation for f composed with g over to the right. Okay, again, this is f composed with g, which is f of x plus 1. Okay, so if my function f of x has an x squared, that's going to make, when I plug x plus 1 in the place of x, that's going to make x plus 1 quantity squared. Okay, so I'm going to calculate this over to the right here. Okay, so if I were to expand out x plus 1 quantity squared, that's going to make x squared plus 2x plus 1. Which is good, like that's a good start for me, okay? Because now I have the x squared underneath the radical like I want, and I also have that constant term 1 under the radical like I want as well, okay? The term that I have to get rid of is the 2x term. So if I make my function f of x subtract 2x, like at first glance you might think you're done because that gets rid of the 2x term, but that's not necessarily the case with this. Because if my function f of x has a minus 2x, that means I have to plug x plus 1 in the place of x in that function as well. Okay, which means I have to, if I'm taking f composed with g, I have to subtract 2 times the quantity x plus 1. Okay, so when I perform that calculation over on the right here, when I distribute negative 2 across both of those terms, we get minus 2x minus 2. Okay, so the good news is that gets rid of the 2x term. But now when we look at what we have underneath the radical, like our constant term, we have plus 1 minus 2, which is going to give me a minus 1 underneath the radical. And I want what's underneath that radical to be plus 1, which means I have to add the constant 2 to my function f of x. So when I add 2 to the function f, that's going to add 2 here, and then that's going to make that negative 2 cancel with the positive 2, and that leaves me with the square root of x squared plus 1, which is what we want that composite function to be. Okay, what we did here, guarantee you're going to have something like that on your Chapter 1 test whenever you take it. Okay, so make sure you know how to do an example like that. All right, so that's going to wrap up section 1-4. I'll post the homework in the week 4 folder. Make sure you have it done before your first block meeting of the week. Okay, hopefully you're studying hard for the quiz on Monday. Let's get the semester off to a good start. Hope you guys have a great weekend. We'll see you tomorrow.